Good morning students, this is Vinayak. I welcome you all for my online session of matrices. Right? So this is my second video on matrices. So in my previous session, that is in my previous video, I have given the introduction, I have explained the definition, and also I have given the information about order of matrix. So what is basically a matrix? From last class we have seen that matrix, the definition of matrix is nothing but it is just a systematic arrangement of numbers in the form of rows and columns and representing them inside the square bracket. There is nothing but representing the numbers in the form of rows and column and blocking them inside the square bracket. Right? And coming to order, what is order? So we have already seen, we have discussed a lot of details about order of matrix in my last session, right? But still I want to give some small highlights about that. Order is nothing but order is nothing but it gives the information about number of rows and columns. If you want to simply define order, it just gives us the information about number of rows and number of columns present inside the matrix. Apart from giving the information about number of rows and columns, it also signifies the number of elements present in the matrix. So it also signifies the number of elements present in the matrix. So for example, if the order of matrix, which is generally defined as m cross n, where m represents the number of rows and n represents the number of columns, if you see that if the order of matrix is 2 cross 2, if the matrix is containing 2 rows and 2 columns, then the total number of elements present inside the matrix is 2 into 2, that is nothing but 4. If the order of matrix is 2 cross 3, that is if the number of rows are 2 and number of columns are 3, then the total number of elements present inside the matrix is 2 into 3, that is 6. So how do we get that? Just multiply the number of rows and columns. That is, if you want to know the number of elements present inside the matrix, then you need to multiply m and n. So m into n will give you the information about number of elements inside the matrix. Right? This was about definition and order, which we have learned from the last class. So let's continue with the from the last session. So in today's session we are going to learn how to represent the elements inside the matrix. How to represent the elements inside the matrix, that is what we are going to learn from today's session. Apart from that, what is the general form of the matrix and also the types of matrix. Okay. So representing the elements in the matrix, right? So the element in ith row and jth column can be represented as Aij. You can observe here, it is Aij. What is Aij? It is the element which is present in ith row and jth column. It is the element present in ith row and jth column. So suppose if any element is present in first row and first column, then it can be denoted as A11. So the first subscript here represents the row and second subscript represents the column. So if it is A11, it is nothing but element in the first row and first column. If it is A13, it is nothing but the element in the first row and third column. Similarly, if it is A22, then it is the element in the second row and second column. So it continues so on. You can name any element according to this rule. Right? This is about how to represent the element in the matrix. So now coming to general form of the matrix, right? When you represent the elements in the matrix, it looks somehow like this. It looks somewhat this way, right? Where first row, first element is represented as A11, first row, second element is represented as A12, first row, third element is represented as A13, and so on. If you continue, somewhere in between you get A1j. What is A1j? This is any random element which is present in first row and jth column. It is the any random element or any element present in first row and jth column. So if you still proceed, the last number what we assume will be as A1n. Why it is 1n? Because it is the element from the first row and nth column. It is the element from the first row and nth column. So if you come to second row, A21 is the first element in the second row. That is 21 represents second row and first column. So A21 is the element in the second row and first column. Similarly, A22 is the element in second row and second column. A23 is the element in second row and third column. Similarly, if you proceed, you get A2j, which is element of the second row and jth column. Still, if you proceed, what will be the last element of this row? It will be A2n. What will be the last element? It will be A2n. That is nothing but element in the second row and nth column. Element in the second row and nth column. Similarly, you can see A31, A32, A33, A3j, A3n. These are all the elements of the third row and first, second, so on up to nth column. So similarly, if you see here, you get AM1. What is this? This is AM1. What does it represents? The element in the mth row and first column. You can see this is the element in the mth row and first column. Then comes AM2, which is element in the mth row and second column. AM3, element of mth row and third column. So on up to AMJ. So on up to AMJ. Sorry, this should be J. AMJ. That is nothing but element of the mth row and jth column. So on, if you come, last element will be AMN, which is nothing but element of the mth row and nth column. So this is how we are going to represent the general, this is the general form of the matrix. This is how we are going to represent all the elements inside the matrix. I hope these things are clear, right? So the first part here represents, the first subscript represents the number of rows or the number or the row in which the element is present, and second subscript represents the column in which the element is present. I hope these things are clear. So this is how we are going to represent the general form or matrix in the general form, right? So coming to types of matrix, this is very important, right? What are the different types? If we know the things, what are the properties, how do we classify them, then it will be easy for us to proceed with the problems or to calculate the values of matrix, right? So these types, the information, the property of these different types of matrix plays a very important role in different types of operation, right? Different operations of on the matrices, right? So coming to types of matrices, first one is column matrix, second one is row matrix, third one is square matrix, fourth one is diagonal matrix, fifth one is scalar, sixth one is identity, seventh one is zero or null matrix. These are different types of matrices, right? So this is how we classify the matrices. Apart from this, there are many other types, right? So you get n number of classifications in matrices, but according to your syllabus point of view, these are the 7 major classification of matrices, right? So what we have discussed in this thing, we know what is how to represent the elements in the matrix, what will be its general form, and what are the types of matrices. Now I ask you people to pause the video and take the note of this. Okay, pause the video and take a note of this. So friends, let's see what are the different type of matrix, as I already listed few moments before. So now let us see what are the types of matrix. As we know, first one is column matrix, right? So what is a column matrix? So any matrix having one column and many rows, we term it as column matrix. So what is a column matrix? Any matrix having one column and many rows. By the name itself you can identify what is a column. Where do we hear about columns? So columns are nothing but, so we have already, this word is familiar to us, right? We find this word in construction purpose, right? Like in any building we have columns, they are nothing but pillars. So how do they appear? They will be slant and vertical. So same meaning is here, right? The same means here also. So what is a matrix? Any matrix which has only one column and many number of rows. It may be one row or more than one row, but column should be only one, right? So here you can see 2, 3, 1. So how many rows it is having? 1, 2 and 3. It is having 3 rows, right? So, and how many column? Only one column. So it is called as column matrix. And what will be the order of this? As number of rows is 3, it is m value will be 3, and number of column it is 1, so n value will be 1. So the order of matrix will be 3 cross 1. So take one more example, right? 2 and 1. This is a column matrix having 2 row and 1 column. So if you want to generalize these things, right, you can write it as Aij, right? Aij, whose order is m cross 1, where m is number of rows and 1 is number of column. It can have m number of rows and only one column. Okay, I hope this column matrix is clear. Coming to next, that is row matrix. This is exactly opposite to that of the column matrix. Row matrix is exactly opposite to that of the column matrix. So what is the definition? Matrix having only one row and many number of columns. So matrix having only one row and many number of columns, right? So example for this, you can see 2, 5, 6. How many rows are there? Only one row. How many columns are there? 1, 2 and 3. So there is one row and 3 columns. So the order of the matrix will be 1 cross 3. So the order of the matrix will be 1 cross 3. Coming to second example, here you can see B is a matrix, right, which is 5 and 3. So how many rows? Only one row. And how many columns? 1 and 2. So what will be the order? 1 cross 2, right? So in general it can be written as Aij, where order of the matrix is 1 cross n. It can have only one row and it can have as many number of columns. That is, it can have n number of columns, right? So I hope row matrix and column matrix are clear. So we'll proceed to the third one, which is square matrix. What is a square matrix? As we know, square is anything where height and length are equal. All four sides are equal, then we call it as a square. Length and breadth both are equal, then we call it as a square according to geometrical considerations, right? So the meaning of square here also means the same thing. That means matrix should have equal number of rows and equal number of columns. Any matrix which is having equal number of rows and equal number of columns, we call it as square matrix. For an example, you can see Aij m cross m. If number of rows are m, then the number of columns should also be equal to m. You can write it also as n cross n, where number of rows are n and number of columns are n. Both way is correct. Okay. So coming to some examples, you can see it is having, A is a matrix having 2 rows and 2 columns. It is having 2 row and 2 column. So what is the order of the matrix? 2 cross 2. So coming to second example, it is having how many rows? The matrix B is having 1, 2 and 3 rows. So how many columns? 1, 2 and 3. So number of rows are equal to number of column. So it is a square matrix and order is 3 cross 3. Coming to third one, you can see there is only one element, but still it is a square matrix. Why? Because number of row is 1 and number of column is well as 1. So the order of the matrix is 1 cross 1. Right? So as I have said before, order also signifies the number of elements present inside the matrix. If you see here, what is the order? 3 cross 1. So 3 into 1 should be 3. So is there 3 elements here? Definitely. Coming here, what is the order? 2 cross 1. So 2 into 1 is 2. How many elements are there here? 2 elements. If you take anything, if you take this one, right? So order is what? 3 cross 3. How many elements are there? 3 into 3, there should be 9 elements. Are there 9 elements here? Definitely yes. So order also signifies the number of elements. I hope square matrix, row matrix and column matrix are clear. Now as usual, as our usual practice, you pause the video here for a few seconds, then take down all the notes and we'll come up with the other types of matrices once you note down all these things. Okay, note it down. Okay friends, I hope you have taken down those previous types of matrices. So now let's continue with the fourth type. Which is the fourth one? That is diagonal matrix. So what is a diagonal matrix? As the definition says, it is a square matrix with all non-diagonal elements being equal to 0. Right? So it is a square matrix with all non-diagonal elements being 0. So what are diagonal elements and what are non-diagonal elements? So that is very important to learn here to understand what are the diagonal elements and what are non-diagonal elements. And one more thing, as it says at the starting statement itself, it is a square matrix. What do you mean by square matrix? Definitely there the number of rows should be equal to number of columns. Once again, you no need to mention that one. Any diagonal matrix or any matrix which is diagonal, there is definitely a square matrix. There is no need to mention it separately. So as it is said, it is a square matrix. That means definitely diagonal matrix is a square matrix and it also having the number of rows equal to number of column. And coming to diagonal elements and non-diagonal elements. So what are diagonal elements? So basically for any square, right, you can have two diagonals. One starts from the left top corner and ends at the bottom right corner. Other one starts at the bottom right, top right corner and ends on the bottom left corner. So here, so the diagonal which is starting from the top left corner and terminating at bottom right corner is called as principal diagonal. The diagonal which is starting from the left top corner and ending at right bottom corner is called as principal diagonal. So here diagonal elements means the elements which are present on the principal diagonal line, right? The elements which are present on the principal diagonal line. So here there is no need to mention it as principal diagonal. So if it is mentioned as diagonal, then that is definitely a principal diagonal. So what it is saying, it is a square matrix with all non-diagonal elements being 0. So you can see the example here, 1, 0, 0, 2. So the diagonal elements, we have the value as 1 and 2, and what are the remaining values here? All other values except diagonals are 0. Coming to this one, you can see you have 1, 2, 3 in the diagonal, right? These are the elements on the diagonal or diagonal elements. Remaining all elements are 0. So this is how the diagonal element will be there. Okay. So I hope the diagonal type of matrix is clear. Coming to next one, scalar matrix. So observe here, what is the definition? It is a diagonal matrix. What is scalar matrix? It is a diagonal matrix. Once again, what do they state here? If it is a diagonal matrix, then it should be definitely a square matrix, right? As we know, diagonal matrix is a square matrix. so there is no need to mention it as a square matrix again and again here. If it is mentioned as diagonal matrix, then definitely it is a square matrix, right? Number of rows and number of columns are equal, right? So as it is mentioned as diagonal matrix, definitely it is a square matrix. So coming to next part, what they say, it is a diagonal matrix in which all the diagonal elements are equal. So when they say diagonal matrix, definitely it is a square matrix. And what is the second property of diagonal matrix? All non-diagonal elements should be 0. All non-diagonal elements should be 0. When they say about diagonal matrix, there is no confusion that there is any element present, any value present in the non-diagonal elements which is not 0. Right? Definitely all the values in the non-diagonal are 0. So what is one more thing? It is a diagonal matrix in which all the diagonal elements are equal. Non-diagonal elements are 0, that is compulsory. And what is the condition for diagonal elements here? They should be equal. Right? Once again I make it clear, as it is a diagonal matrix, so it will be a square matrix and non-diagonal elements will be 0. And what is the second condition here? Diagonal elements should be equal. So here you can see 2 and 2. Here if it is 2, definitely here it should be 2. Remaining else will be 0. Right? Coming to this one, 5, 5, 5. Any number which is there in which is there on one portion of the diagonal will be on the entire diagonal. 5, 5, 5, 0, 0, 0. Remaining things. It may be 7, 7, 7. It may be 3, 3, 3. Anything. Right? So this is about scalar matrix. Is that clear? So this is how we can define diagonal matrix and scalar matrix. Coming to sixth one, identity matrix. Right? So identity matrix. So what is identity matrix? Once again they say that it is a diagonal matrix. What do you mean by diagonal matrix? Definitely it is a square matrix and non-diagonal elements will be 0. Right? It is a diagonal matrix with diagonal elements being 1. What do you mean by that? It is a diagonal matrix. Definitely it is a square matrix and non-diagonal elements are 0. That is very sure. And one more condition is diagonal elements should be 1. Whatever elements are there on the diagonal part, they should be 1. Right? Here you can see 1. There is only one element. So this is the only principal diagonal elements. So that is 1. Coming to second one, you can see here 1, 0, 0, 1. Right? So this is how we define the identity matrix. So what is identity matrix? It is a diagonal matrix where all its diagonal elements are 1. Remaining are definitely 0 as it is a diagonal matrix. So any diagonal matrix, any identity matrix of order n can be represented as IN. I represents or I stands for identity and n is the order. Right? Here there is no need to mention it as n cross n. If you mention it as n, definitely it means that it is n cross n because it is a diagonal matrix. As it is diagonal matrix, it should be a square matrix. So number of rows will be equal to number of columns. So if the order is n cross n, if the order is generally n, then we can represent the identity matrix as I subscript n. So is that clear, students? What is identity matrix, scalar matrix and diagonal matrix? So let's come to the last type or last classification of the matrix, that is zero matrix. What is zero matrix? As generally 0 means the elements whatever is there or the value of the matrix should be equal to 0. That is the general meaning. So that is also true here. So zero matrix, it is a matrix having all its elements as 0. It is a matrix having all its elements as what? 0. So you can see here, if the order is 1, there will be only one element, that is 1. If there is order 2, if all the elements will be 0, 0, 0. Here you can see all the entries are 0. Coming to this one, what is the order of this? 2 rows and 2 column, 2 cross 2, 3 rows, 3 column, 3 cross 3. Coming here once again it is 2 cross 2, 3 cross 3. Here 1 cross 1, 2 cross 2. Here 1 cross 1, 2 cross 2, 3 cross 3. Is that clear? How to write down the order and how to define them. These are the simple definitions. These are simple definition, right? These definitions are very much simplified. So you can go through the books. You find different types of definitions in different types of books. So kindly go through many books, and most preferably NCERT. So go through the NCERT book. You will get lot of explanation about these things, right? So in case if you have any doubt, you can get back to me, right? You can comment in the comment box, so you can get back to me. Is that clear? So take a moment, pause the video as usual, and make a note of these things. Okay? Okay, fine. I hope you all noted down these things. So with this simplest definition, simplest classification, right, we'll wind up this session. So what all the things we have learned in this session? First one is how to signify the element in the matrix, how to consider the matrix, right? What is its row, what is its column, everything we have learned, and how many elements will be there in the matrix, how to identify, if you know the order, everything we have learned. Then different types of matrices, its classification, general form, everything we have learned here. I hope these things are very much clear. I have made the things clear. So still if you have any doubt, as I said, you can comment me in the comment box, right? So these are the simplest things. So we'll wind up it here. Okay. Thank you.